and sine theta, minus 1 minus sine theta and 1. Then for all theta belongs to 3 pi by 4 comma 5 pi by 4, det of A lies in the interval. So basically we have to find the interval of this, correct? No? So how to find the interval of this, right? We will, although this can be done by different method, but we will go very simple, right? First find the det of A. So how to find the det of A, right? We'll write this, and this will become 1 minus of sine square theta. So this will become 1 plus sine square theta. Then we'll write minus sine theta. I hope everybody know how to find the det of this. So minus of sine theta, block this, this will become minus sine theta and minus sine theta plus 1, correct? Minus sine theta, and this will become minus sine theta and plus sine theta, this will become. And lastly it will become plus 1 I will write here, and this will become sine square theta plus 1. Right, so this will become 0, right? Minus theta. So only we have 1 plus sine square theta and here 1 plus sine square theta. So I can write it as 2 into 1 plus sine square theta. Right? Now this is the value of det we are getting, 2 times of 1 plus sine square theta. Right? Now from here we can do now how to do this. We have to find the value of theta. So just see what is the maximum value we can get. So sine theta is where? Theta is given as 3 pi by 4 to 5 pi by 4. If you see the graph of this, it will look like this, correct? No? So 3 pi by 4 is what, 135 degree. Basically it will lie somewhere here, and 5 pi by 4 is how much, 225 degree, that's here. So this value comes 1 by root 2, and this value is minus 1 by root 2, right? So sine theta will basically lie from where to where? It will be greater than, because this is the open interval they have used. So minus 1 upon root 2, and this will be less than 1 by root 2, correct? But we don't have to find the value of this. We have to find the value of sine 2 times of 1 plus sine square theta. So if sine theta is in between minus 1 by root 2 and 1 by root 2, so sine square theta will become what? Because the square cannot be negative, no? So sine square theta, the moment we'll do sine square theta, it will be what? Greater than or equal to 0 and less than 1 by 2. But still we don't have to find that. We have to 1 plus sine square theta. So 1 plus sine square theta, everywhere we'll add 1, this will become 1, and 1 plus half will become how much? 3 by 2. Now 2 times of this. So if I'll multiply 2 here, so this will be 2 less than, this will become here 2 times of 1 plus sine square theta, and less than, this will become 3, right? So it means this value will be lies in the interval between what? If this will lie in the 2 close interval and 3 open interval. But you will find there is no such option, right? 2 close interval and 3. But if you see option number B, it is from where? It is much wider range. This is the much wider, because 3 by 2 it means 1.5, and this will go till 3, right? So option number B is the correct option, right? Because it starts from 3 by 2, which is very much in between like 2 and 3, and this is wider range they have given, right? So the correct answer is B, 3 by 2 comma 3. So now we'll move to next question. Right? I hope everybody is done with question number 1. Now we can move to the question number 2. Let's see what is the next question. Next question we are writing is, I am erasing the first question. Okay, so the next question is, this is also from the matrix. This is question number 2. The number of symmetric matrices of order 3. Of order 3 means what? It should be in a 3 cross 3 matrix, right? With all these with all entries from the set, and what is the set given? Set is given as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, correct? Is okay. So this one is easy problem. Just see how. First of all, how to form the symmetric matrix. How to form the symmetric matrix? We'll form the symmetric matrix. Any format of the symmetric matrix will be what? First we'll write the format of the symmetric matrix. Symmetric matrix is what? A and A transpose will be equal, right? So first we'll find the solution. We'll write the format A. Let's suppose you are writing it as A. Then if you are writing it as B, no, so this and this should be equal. If you are writing it as B, so this will be B and B. These two entries should be equal. And then this part C and this should be C should be equal. Now this you can name it as D. This and this is E, so this will be also E and this is F, right? So how many unique entries we have in forming the symmetric matrix? How many unique entries do we have? If you see A, B, C, D, E, F, right? So 6. And everywhere, no, if at the place of A, how many choices do I have? I have 0 to 9, anything I can fill, no? From 0 to 9, anything I can fill. So if I want to fill A, I can fill it from this 10 choices. And everywhere I have the same 10 choices, right? So everywhere I have the same 10 choices. So what I will do, this will become what? 10 into 10 into 10. How many times? It will become 10 into 10 into 10. 6 times, right? So the answer of this problem will be 10 to the power 6. Means 10 to the power 6 symmetric matrix we can form with the help of these entries, right? Because there is always, no, we can select A as 10 ways, B as 10 ways and C as 10 ways, correct? No? So this is the solution for that. Write it down and then we'll move to question number 3. Next we'll move to question number 3. Next we'll see what is problem number 3. Just see. Okay. The number of matrices of the order, the number of matrices of the order, again the order is given as how much? 3 cross 3. Order is 3 cross 3, whose entries are 0 or 1. Whose entries are 0 and 1, and the sum of all entries is a prime number. Right? Prime number. So what it should be means all the entries is what? We know the format how to write a 3 cross 3 matrix, right? 3 cross 3 matrix can be written as simple, right? I will write it down first the format, just like the previous case. We can write it as A11. What do you mean by A11? A11 is the first row, first column. Similarly, I can write it as A12, A13, right? I hope you know this. A11, A12 and A13. Similarly, this could be written as A21, A22, A23. And the last row A31, A32, A33, right? What does this represent? It represents as first row, first column. Similarly, represent third row, second column. I hope this no. Now, what is the problem saying? The problem saying when you add all the entries, no, it should, and entries should be only 0 or 1. We cannot have any other thing, but only 0 or 1. And the sum of the entries should be what? Means if I represent it as I and j, then the summation of all the entries, like summation of A, I, j, that should be equal to how much? Either it should be a prime number, right? So prime number can be, it could be 2, 3, or it could be 5, it can be 7, and no other prime number, because the maximum if I'll put now 1, 1, 9 times. Okay, so 9 is not the prime. So 2, 3, 5 or 7. So basically we require 2, 3, 5 and 7. Now how many ways we can make it 2? It can be like, if 2 entries we fill it by 1 and the rest 0 and the rest is 0, so we can write it as what? 9C2. 9C2, any 9 entry we can fill it by 1, so that it will become 1 plus 1, 2, and the rest all 0. So that could be, we can make it at 9C2 ways. Other is again 9C3. We will using 3 ones, right? 3 ones, so 9C3. For 5 ones, we can write it as 9C5, and for 7 ones, we can write it as 9C7. Now this is very simple. 9C2, this could be 8 into 9 divided by 2, and this will become how much? 36. 8 9 is 72, 36. Okay. And what about 9C3? 9C3 will become what? 9 factorial, 9 minus 3 factorial, that is 6. So I can write here 7, 8, 9 divided by 3 factorial, that is 6. And what about 9C5? So 9C5 will be 9 factorial and 9 minus 5, 4 factorial it will be, right? So here it will be 5, 6, 7, 8 and 9, and divided by how much? Divided by 5 factorial, that is 120. And last 9C7, there is no need of calculation, because 9C7 will be equal to 9C2. 9C7 and 9C2 are equal, so I am just writing it as plus 36. They both will be same. Now calculate this, how much it is coming. This can be 3 2s are 6, 3 3s are 9, 2 4 are 8, 4 3s are 12, and plus this, I think this will be 84. Just keep on cross checking the calculations, and this will become how much? 5, and this will be 24, 6 and 4, 4 2, 9 2, 18, and this will become how much? 126, I think. 18 into 7, right? 126, and this will become how much? 36. So 36 and 36, 6 6, 12, 4 16 and 2, right? This will become 3 2 5, 5 8 13. This will become how much? 6 6 12 and 4 16 and 6 22, 5 7 15 and 18, and this will become 282. So I think 282 is the final answer, right? So the number of matrices that will form is, how much is the answer here? 282. Just cross check the answer. Then we'll move to some other types of problems. Write it down and then we'll move to some other type. Answer, final answer is 282. Now we'll move to question number 4. Just see what is the question number 4. Question number 4 I am writing. I am erasing all. Okay, question number 4 is, let A plus 2B is equal to 120, 120, 6 minus 3 and 3, minus 5, 3 and 1, and 2A minus B is equal to 2 minus 1 and 5, 2 minus 1 and 6, and 0, 1 and 2. Okay, so something is given as a plus 2b as this thing and 2a minus b as this thing. Correct. Now if trace of a, what do you mean by trace? Sum of the diagonal elements, right? So if trace of a denotes the sum of all diagonal elements of the matrix A, then trace of A minus trace of B has value equal to, right? Just see how we can do. So basically we have to find the trace of A minus trace of B. So first we will find the trace of A and trace of B, right? Once we get the trace of A and B, the rest is subtraction only, right? So let's see how we can get the A plus 2B. So can we write, and we will utilize some of the properties of, some of the properties of trace property, right? Trace of A plus B. So trace of A plus 2B can be written as how much? Trace of sum of the diagonal elements will be 1 plus minus 3 plus 1. So I can write it as 1 plus minus 3 plus 1. That is equal to how much? 2 minus 3, that is minus 1. And by utilizing this property, I can write it as trace of A plus 2 times of trace of B is equal to minus 1. Let's suppose this as equation number 1, right? Trace of A plus 2 times of trace of B is equal to minus 1, and we are denoting this as equation number 1, right? Then we'll solve this. How to write trace of 2A minus B? Trace of 2A minus B is what? We can write it as how much? 2 minus 1 and 2. So we can write 2 plus minus 1 plus how much it is? 2. So this will become 4 minus 1, that is 3. Now this, again we will utilize the property. We can write it as 2 times of trace of A minus trace of B is equal to how much? 3. And let it be equation number 2. Correct? These are equation. Now we'll solve the equation first and second. How to solve the first and second equation? Either you multiply the equation first by 2, or better multiply the equation second by 2. It will become easy, right? So if I multiply the equation 2 by 2, it will become here what? 2 times of trace of B. So I can write here, instead of writing no, so I am writing here trace of A plus 2 times of trace of B is equal to minus 1, and when I multiply this by 2, it will become what? 4 trace of A plus, this will be minus 2 trace of B is equal to how much? 6. Now both of them, how much this will become? 5 times of trace of A is equal to how much? This is 5. So trace of A basically becomes what? 1. Once you get trace of A as equal to 1, then we can put in any equation, either first equation or second equation. So from here, if I put trace A is equal to 1, this will be go that side. So 1 and minus 1, minus 1 and minus 1, minus 2, and this will become trace of B. Trace of B will come as how much? Minus 1. Correct, no? So, but they are not asking trace of A and trace of B separately. They are asking trace of A minus trace of B. So this will become what? Trace of A minus trace of B, that is equal to 1 minus minus 1, and that is equal to how much? 2 is the answer. Final answer will be 2 here. Final answer will be 2. Right? Trace of A minus trace of B, because trace B comes as equal to, I think, minus 1. So 1 minus minus 1, and the final answer in this will become 2. Make a note of it, and then we'll move to the question number 5. I hope you guys are getting, right? What is the next problem? Question number 5. Okay, next time writing down problem number 5. Question number 5. If for the matrix A is equal to 1 minus alpha and beta, AA transpose is equal to I2. What do you mean by I2? Any identity matrix which is of the form of 2 cross 2, right? Then value of alpha to the power 4 plus beta to the power 4. Options are given as 4, 2, 3 and 1. 4, 2, 3 and 1. Just see how we can find. AA transpose is given as what? I2. I2 is what? Identity matrix of 2 cross 2. What do you mean by identity matrix? The diagonal elements are 1 and the rest are 0. Right? So we'll first see how to write the AA transpose. I think property, if you will apply property, it can help. But even if you don't apply property, you just do something direct multiplication. That is also easy, right? So better do a multiplication. Let's see. AA transpose, no? AA transpose is equal to I2. AA transpose is equal to I2. So I will write here 1 minus alpha, alpha and beta. And this will become what? If you do the transpose, no? So this will become here, minus alpha will come here, alpha will go there, and this will beta. Now this is already given how much? 1, 1, 0 and 0. Now see, from here we will get something, right? Matrix multiplication we know, it is easy, right? First row with the first column, first row with the second column, and second row with the first column, and then second row with the second column. So how to do? This will become what? 1 plus alpha square, and that will be equal to 1. First row, second column, it will come what? Alpha and minus alpha beta, and that is equal to 0. And second row, first column is alpha and minus alpha beta, and that is also equal to 0. And last is alpha square plus beta square. Alpha square plus beta square is equal to how much? 1, right? So since there are only 2 unknowns, no, alpha and beta, so we will make use of only 2. So I think this will help, because from here, no, that implies that alpha square is equal to 0. So alpha will become here what? 0. So one of the values of alpha value we got. Now same alpha value if I put here, no, so that from here I can get beta square is equal to what? 1. But how much they are asking? They are not asking alpha and beta. They are asking alpha to the power 4. So 0 to the power 4 and this thing, it is correct. Alpha and beta 4. So alpha to the power 0, 0 to the power, this will become anyway 0. And this is 1 to the power 4, right? So beta square is, so it will be 1. So final answer I think is 0 plus 1, that is 1. Right? Again, this was easy problem. This was question number 5. And next we'll move to question number 6. Just write it down so that we can move to the question number 6. Okay, now we are moving to question number 6. Just see what is question number 6. If A is equal to 0 sine alpha 0 and Det of a square minus is equal to 0. This is also given as det of a square minus half I is also given as 0. Then possible value of alpha is, what is the possible values of alpha? So options are given as pi by 2. This is pi by 2. B is given as pi by 3. C is given as pi by 4. And D as pi by 6. Right? So this also you can do by simple multiplication, right? So first we can do what? A square first we find, and then we'll find minus half of I. What do you mean by minus half of I? Half will be multiplied by the identity matrix. Identity matrix, half multiplication. Okay. So just see how we can do. First we'll find the A square basically. So A square how we can find? Write it as A square will be, this thing you will write 0 sine alpha 0, and this thing you will multiply 0 sine alpha and this is 0. So how much is this coming multiply? First row, first column, this will be 0 plus sine square alpha. So sine square alpha. And first row, second column, 0 and this is 0. This will become again first row, second column. Second row, first column. So 0 and this will again become 0. And this will become sine square alpha. So basically this comes out to be A square. And what do you mean by half of I? Half of I means what? Minus of 1 by 2 here and 1 by 2 here. And 0 and 0. This will be multiplied by half now. So this 0 will have no change. And only diagonal elements where it was 1 in the case of I, this will change as half, right? Now do the subtraction. Subtraction is very simple, no? Sine square alpha minus half. And here it will be 0. And this will be 0 here, and here also you will write it as sine square alpha minus half, right? We are not applying any property. We are just doing basic simple calculation. Now how to find the det of this? Det of this will become what? This I can write as sine square alpha minus half whole square minus 0. So basically this comes out to be det, because minus 0 is what? Nothing, right? So sine square alpha minus half whole square, that is 0. And that is already given. This is already given, right? So this is equal to 0. So I can write it basically what? Sine square alpha minus half is also equal to 0, right? This square has no meaning here. Now this will become what? Sine square alpha is equal to half. So basically that will give you what? Sine alpha is equal to how much? Sine alpha is equal to 1 by plus or minus 1 by root 2. Plus or minus 1 by root 2, right? So plus or minus 1 by root 2, this will be what? At which point we have sine alpha? Okay, so pi by 4, right? So alpha possible value will be what? Pi by 4, because we know sine 45 is 1 by root 2. So we'll get pi by 4 here, sine plus or minus 1 by root 2. So pi by 4 is the possible answer, correct? This was your question number 6. We'll move to next question, question number 7. Now we are moving to question number 7. Just see what is question number 7. What is question number 7? And these are all previous year question, right? PYQs. So we'll move to question number 7, and that is, if P is equal to 1, 0, half and 1, then p to the power 50. P to the power 50 is very simple question, right? If p is given as 1, 0, half and 1, then we have to find the p to the power 50, right? Options are given as 1, 0, 25 and 1. B option is given as, here it is 1, 25 and 0 and 1. Option C is given as 1, 50, 0 and 1, and D option is given as 1, 0, 50 and 1. Correct, no? Just see what they are saying. If P is given as, P is given as 1, 0, half and 1, then only we have to find what? P to the power 50. Actually, P to the power 50 by calculation we cannot do, right? So we have to see some pattern, in which pattern it is going, right? So we have to basically find the pattern. Okay, just see how we can do P. First we'll write P. 1, 0, half, and this is 1, right? Then how to find the P square? P square is simple, no? We will multiply P with P. So 1, 0, half and 1. Multiplied by here, 1, 0, half and 1, right? Follow the same pattern. First row, first column, first row, second column, second first, and then second, second. Just see how we can do. 1 into 1 is 1, and this will become 1 only. Again, first row, second column, 0, this is 0. This is coming 0. Then 0 into half is half plus half. Half plus half is coming 1. And then half into 0, 0. And then 1 into 1 is 1. So this will come as, so this comes out to be P square. This comes as P square. P square is coming as 1, 0, 1 and 1. Now let's see for the PQ, right? So PQ will be what? P square into the P, right? So we can multiply 1, 0, 1 and 1 with what? The P. And what is P here? 1, 0, half and 1. Correct, no? So how to find? Again, same thing. We'll do here. First row, first column, that is 1, and this is 1. 0 into half, done. First row, second column, 0 and 0, this is 0. This will become 1, and this will become how much? Plus half. 1 and plus half is out. 3 by 2, right? Is it 3 by 2? Yes. And this is 1, 0, 0, and this is 1. So this is. So this comes out to be P by 3. You see, you notice one thing, no? The entries are not changing. The entries A11, A12, and A22. These three entries are not making any change. 101, 101. Only this is changing, right? 1, and this is changing to 1. So half is added here, no? So 1, and this becomes what? 3 by 2. So this is only changing. Now, how to go for P to the power 4? One more thing we can check now. Let's see, are we correct or not? So 1, 0, 3 by 2 and 1. This is your PQ, and multiplied by the initial. Initially was what? 1, 0, half and 1. This is your P. Now make the multiplication. 1 into 1, this is 1, and 0, this is again 1. First row, second column, this is 0 and this is 0, again 0. 3 half, and this is becoming 3 by 2 plus 1 by 2. 3 by 2 plus 1 by 2 is 2, and this has 0 and this has 1. Okay. So now you notice, we are confirmed that these three entries are not changing. A11, A11, A12, A22. These three are not making any change. Only entry that is changing is A21. And it is changing in which pattern you see, no? It is starting with P is here. When it is P, it is half. When it is P square, it is 1, right? When it is P cube, it is 3 by 2. It is increasing half and half, right? So at P to the power 50, no? What will become P to the power 50? This is done, no? 1, 0, 1. There will be no. When it is P4, no? P to the power 4, it is 2. It means exactly half. So at P to the power 50, it will become what? This element will become, this entry will become, no? This entry will become 25. This entry will become 25. So answer you find which option is 1, 0, 1, 25. Option number A is the correct option. Correct. So this way, although we could have stopped here, but it is always safe to find at least P2, P3, P4. Correct. So we can confirm. Write it down and then we'll move to other problem of this kind, the pattern based or the repeated pattern. Next will be question number 8, right? Okay, so now we will write question number 8. Question number 8 is I'm writing next question. Okay, just see the next question. Let A is equal to 1, 0, 0, 0, 1 and 1, 1, 0 and 0. This is your A. Then A to the power of 2025, A to the power 2025 and A to the power of minus A to the power 200, right? Is equal to what? Is equal to. So basically we can see it is same as previous one, right? This will be a problem. Is equal to what? Option number A is A to the power 6 minus A. B is A to the power 6. C is A to the power 5 and D is A to the power 5 minus A. And this is from the year 2021. This is from the year 2021. Just see how we can do. Again, start finding A square, A cube at least, so that we can see some of the pattern. And this is a 3 cross 3 matrix. This is a 3 cross 3 matrix, right? So be little bit calculative. Let's see how we can do. A is there, no? A is there as 1, 0, 0, 0, 1 and 1. And I can write here 1, 0 and 0. Done? So start with A square, no? Why to A square? A square, how to write? A square will be 1, 0, 0 and 0, 1, 1, 1, 0, 0, right? Start making the calculation. First row, first column. Just see what is the A square getting. What is the A square getting? First row, first column. This will become 1. This will become 0. This will become 0. So only 1 will be there. First row, second column. This will become 0, 0, 0. Okay, so this is 0. First row, third column. 1 into 0, 0 into 1 and 0 into. So this is also 0. Correct? And second row, first column. Second row, first column. This will be 0. This will be 0 and this will be 1. So here it is changing. 1. Second row, second column. 0, 1 and this is 0. So here it is 1. Second row, second column. This will be 0, 1 and 0. So here it is also 1. Third row, first column. 1, 0 and 0. So this will be 1. Third row, second column. This will be 0, 0 and 0. So this will be 0. And third row, third column. 0, 0 and this will be 0. Okay, so this. Now observe what is the change we had. The only change is on A to 1. The only change we have is in A to 1. Rest all you see, no? A11, A12, A13, they all are same. So now focus, is it changing in A cube also or in the same manner is it changing? We have to notice that, right? No? A11, A12, A13, rest all are similar, right? 1, 0, 0. Rest all are similar. So just find A cube. A cube, how to find? Just 1, 0, 0, 1, 1, 1 and 100, and that should be multiplied by what? With the initial one. Initial is what? 100, 011 and 100. Now I am multiplying here to save the space now, because we have to go for others. So again multiply. This will be 1, 0 and 1. Okay. First row, second column is what? 0. This will be 0. First row, third column is 0, 0 and 0. So this will be 0 again. Second row, first column, 1 into 1 is 1, and 1 into 0 is 0, and 1 into 1. So this is becoming 2. Again there is change, right? And second row, second column is what? 0. This is 1 and this is 0. So this will be 1. Second row, second column, 1 into 0, 1 into 1. This is also 1. And third row, first column, 1, 0 and 0. So this is 1. This will be third row, second column. Third row, second column. This will be 0, 0 and 0. So this will be third row, last third column, 0, 0 and 0. So this will be 0, right? Now you notice the change, no? It is again only this changes. Rest all remains same. So if you want, you can stop it here, or for the safe side, if you can check. But I think it is okay. It is only showing, no? A2, when it is a square, it is here 1. When we are doing a cube, it is becoming 2. It means it will changing in the pattern of, if I have to find the a n, this will come in the form of 1, 0, 0. This will be 1 less than that power, right? So this will come as n minus 1, and this will come as 1, 1, and the last column will come 1, 0, 0, right? So this is the pattern it will follow. N minus 1. Now they are asking, no, a to the power 2025. So obviously here it will come what? This point will come, no? If I want to find a to the power of 2025, it will come as 1, 0, 0. 2025, no? So here it will come 2024. I have to write it. 0 and 0. So this will come 1, 1. And this will come as 1, 0, 0. And subtraction of what? A to the power 2025 minus a to the power 2020. Right? So 2020 will be what? It will be like this. 2019 here. And rest is same. 0, 1 and 1. Now simple subtraction if you do, no, this will be simple subtraction you do, this will come in the form of 0. Is it coming 0? Yes. 0, 0, 0. 2024 minus 2020, 2019, this will be 5 here. And this will be 0, this will be 0. This will come as 0, 0 and 0. So only element you are getting is 821. The only element you are getting is 8. Now this matrix is equivalent to what? Is it? We have to see in the option. A to the power 6. A to the power 6 will be what kind? A to the power 6. I am solving it here by verifying the options, right? So is it a to the power 6? A to the power 6, it will come as 5. No, it will not come like this. A to the power 5, it will come 4. Rest will. So we have to check. A to the power 5, it will. Okay. So I think option number A is correct. So how to write? A to the power 6 will be what? A to the power 6 will be 1, 0, 0, and here it will be 4, 5. A to the power 6 will be here 5, and minus it is what? A was 0, correct. Huh? So A5, 1, 1, and 1, 0, 0. This is A over A to the power 6, and minus A. The A original was what? 1, 0, 0. The starting was from where? 1, 0, 0, and this was 0, 1, 1 and 1, 0, 0. Correct, no? If you subtract it, we will get no same thing as 0, 0, 0. 5 minus 0 is 5, and 0, 0, and this will be 0, 0, 0. It means now you notice this, no? A to the power 6 minus A is equivalent to A to the power 2025 minus A to the power 2019. So these two are similar, right? Correct option will be what? A option, right? You see A to the power 6 minus A, it is coming as A to the power 2025 minus A to the power 2019, right? So compare it, they both are same. So option is the correct option here. Now we'll move to question number 9. Make a note of it and then we'll move to question number 9. Okay, question number 9 we are moving. Let's see what is the question. I am writing down the problem. Question number 9 we are writing. Just see what is question number 9. Let alpha and beta be real numbers. Consider a 3 cross 3 matrix. Consider a 3 cross 3 matrix such that A square is equal to 3a plus alpha I. If a to the power 4 is equal to 21a plus beta I, then option number A is beta is equal to minus 8. Option number B is beta is equal to 8. Option number C is alpha is equal to 4. And option number D is alpha is equal to 1. Now understand the problem. So alpha, beta are the real numbers, right? And again, this matrix is what? A 3 cross 3 matrix such that A square is equal to 3a plus alpha I, right? So, and if a to the power 4 is given as what? 21a plus beta I, then they are asking the value of beta or alpha, right? So either the alpha option will be verifying here or beta option will be, right? So just start writing. First it is given a square is given as 3a plus alpha I, right? If I squaring on both sides, no, if I square on both sides, it will become a to the power 4. A to the power 4 and this will become 3a plus alpha I whole square. Now do the simple calculation. This will become 9a square. This will become I square does not mean, right? So it will write it as I only. A square plus B square plus 6a alpha. 2 3 is 6, right? 6a alpha I. Anything else? No. So this will become what? 9a square. 9a square plus 6a alpha. And since it is multiplying, no. So we can write 6 alpha A because identity matrix multiplication, right? So we'll write it basically 6 alpha A. And a square can be replaced by what? We can replace the a square as a square can be replaced by here 3a plus alpha I, and here it is alpha square I, and this is what? 6 alpha A. Now if I multiply, this will become what? 27a plus 9 alpha I plus alpha square I plus 6 alpha A. Now you see a and a is here, no? So we can take a common from these two. If we take common from these two, this will become 27 plus 6 alpha, and a is taken common, plus we have to get this form now, 20 a and b, okay. And we can I common from these two. I can be taken common from these two. So what I will get? I will get here 9 alpha plus alpha square, is it? 9 alpha plus alpha square, okay. And here it will be I. Now do the comparison with this 21a plus beta I. 20a 1, okay. So I can write this, no? 27 plus 6 alpha is equal to how much? 21. We are comparing with this a to the power 4, it is given, right? 21a plus beta I. So we are comparing it. And this will give what? 6 alpha is equal to 21 minus 6. So this will become minus 6. Alpha is equal to minus 1. By comparing only. And from here we can compare, no? 9 alpha plus alpha square is equal to how much? Is equal to beta. Is equal to beta. Alpha already we have got minus 1. 9 minus 1 plus minus 1 whole square is equal to beta. Since alpha is equal to minus 1, there is no option. That is why we are finding beta, or else we could have tick. So this will become what? Minus 9 and plus 1, this is equal to beta, and beta is equal to minus 8. Beta is equal to minus 8 is one of the option, right? Option number A. Beta is equal to minus A is one of the option, so we can click it here. Just show the calculation. Done. Okay. Now we are moving to the question number 10. Just see what is the question number 10. Okay, we are moving to the question number 10. Question number 10 is, let A is equal to 1, 2, minus 2 and minus 5. Let alpha comma beta belongs to R such that alpha A square plus beta A is equal to 2i. Then alpha plus beta is equal to, options are as minus 10, minus 6, and this is 10. Now see what this question says. 1, 2, minus 2 and minus 5 is your matrix. Alpha beta belongs to R. And where is the alpha beta? Alpha beta. Okay, so alpha A square plus beta A is equal to 2i. Then alpha plus beta is equal to. Basically, we have to find the value of alpha and beta. Just see how to find the alpha and beta value. Okay, so we will find the characteristic equation of A. So how to find? Very simple. A is given as this thing, no? A is given as 1, 2, minus 2, and this is minus 5. Okay. So what to do? We know that characteristic equation. How to write? A minus lambda I is equal to 0. A minus lambda I will be equal to 0. So A minus lambda I, it will become what? I can write A minus lambda times of I is equal to 0. So that will become what? A minus lambda basically. So this will become 1 minus lambda. We have to find the depth of this. 1 minus lambda, 2 will remain as it, minus 2 will be here, and minus 5 minus lambda, and that depth will be equal to 0, right? So we are finding the characteristic equation, right? So now do the cross multiplication. 1 minus lambda into minus 5 minus lambda, and this will be minus of minus 2. This will be plus 4 is equal to 0. Now see how much it is coming. Minus 5. This will be minus lambda plus 5 lambda and plus lambda square plus 4 is equal to 0. And this can be written as lambda square minus plus 4 lambda and minus 5 plus 4. This is minus 1 is equal to 0. I think it is right. Lambda square plus 4 lambda minus 1 is equal to 0. And we know characteristic equation. This will be satisfied with the matrix A only, right? So it means we can replace our lambda with what? We can replace our lambda with A basically. So I can write it here, no? If it is satisfied by our matrix only A, no? So I can write it as A 4a minus, this will be what, I. So this I can write it as 1 is there, so minus I is equal to 0. Now do the comparison. This is alpha a square beta square. Okay, so I can write it here. A square plus 4a is equal to I. And since there is 2, no, so multiply 2 both sides, this will become 2a square plus 8a is equal to 2i. Now this is correct. Now we can do the comparison with this. Alpha a square plus beta a is equal to 2i. Now if we do the comparison, alpha value is coming as how much? Just simple comparison we'll do now. So alpha is equal to how much? Alpha is coming as 2 and beta is coming as how much? 8. They are asking what? Alpha plus beta. So alpha plus beta will become what? 2 plus 2 plus this will become 8. So answer is 10, right? Option number D is the correct option. 2 plus 8, that is the final answer is what? Correct. Which concept we have applied? We have applied the concept, no, that matrix A satisfies the equation. That which equation? That characteristic equation. So instead of lambda, we replaced it by A, and this can be written as